Good evening, ladies and gentlemen. Tonight we're on Module 3, Lesson 4, and we're going to continue multiplying fractions. So far we have learned 4 different methods. We have learned what we could call kind of our dot method, where we're drawing dots. We have learned our number line method. We have learned a tape diagram method. And then we also learned last night just using what we could call the algorithm, where we multiply straight across. So we've learned 4 methods, and I think it's nice to be able to use different methods for different problems. So I'm going to start with my first problem today, and my first problem is 4/3 of 6. Now what I want to remember is whenever I see this of, I know that that means 4/3 times 6. So for this one, it would be really hard to do a number line, because if I did my number line, watch what would happen. I would have a number line and I would divide it into 6. But then so I have my 6 holes, and then this says that I need to divide it into 3 pieces, each of my holes. But then here's my problem. For each one, I need to shade in 4, but I only have 3 for each hole. So each problem does not work for each method. So a number line method would not work for this problem. And the reason it's not going to work is because this is a greater than 1 fraction. So for this problem, I could use maybe a tape diagram. So I could do a tape diagram, which means I have 6 holes. They want me to divide it into 3 sections. So what would those 3 sections have to equal to be 6 total? Well, they would have to each equal 2. But they said, I don't have only the 3 parts, I have an extra part. I have an extra one to have 4. So I think my answer would be 8. Now, I probably would have just actually done this one. If I was doing this by myself, I would have done this as an algorithm problem, which means I would have changed my 6 to a fraction and multiplied straight across. So I'm getting 24/3. And because this is a greater than 1 fraction, I am going to use division. And I'm going to say 3 goes outside, 24 goes inside. And 24 divided by 3 is 8, with nothing left over. So of the methods, I probably would have gone straight to that one, even though the tape diagram did work. Okay, let's look at my next one. My next one is a less than 1 fraction. So I won't have the same problem that I had with the number line for this one. I would be able to do a number line. But am I going to be able to do a tape diagram for this one? Let's see. If I did my tape diagram, and they wanted me to cut it into 5 parts, am I going to be able to cut 7 into 5 parts? Not at all. So for this problem, a tape diagram doesn't work. So again, different methods work for different problems. I would probably just do my algorithm for this problem. 2/5 of 7 is the same as 2/5 times 7/1. So when I multiply straight across, I get 14/5. And then when I go to correct this greater than 1 fraction, I get 14 divided by 5 is 2, and 2 groups of 5 is 10. So I have 4 left over. And remember, my denominators don't change. So I'm getting 2 4/5. I also could have done a number line for this, but I think the algorithm was the fastest. Okay, one more before we do some together. Now this is why I like to have different methods, because this one's a tricky one. It says Julio has 10 baseball trophies. He has 5/8 the number of trophies that his sister Esperanza has. How many trophies does Esperanza have? Okay, so if I read this really carefully, Julio has 10. Esperanza, we don't know. But Julio has 5/8 of Esperanza's. So this question's actually a tricky question. It says 5/8 of Esperanza's, which we don't know what it is 10. 5/8 of Esperanza's question mark is 10. So for this one, it would be hard to use the algorithm, but it might not be so hard to use a tape diagram for this one. So this means that I have some number. I don't know what my number is, but I'm going to cut it into 8 parts. I'm going to cut it into 8 parts, and 5 of the parts, 5/8 of the parts is going to equal 10. So if 5 of the 8 parts has to equal 10, what do these 5 each have to equal? They each would have to equal 2. Which means my whole number is 2, 4, 6, 8, 10, 2, 4, 6. My whole number is 16. So Esperanza's number must be 16. So that would be my answer. If I wanted to check that, I could say 5/8 of 16, which is 5/8 times 16, and I should get 10. So we could go through and check that. Well, 5 times 10 is 50, and 5 times 6 is 30. So 5 times 16 is 80, and 8 times 1 is 8. So is 80 over 8 10? It absolutely is. But I think I wouldn't have been able to go straight to the algorithm. I think the tape diagram helped on that. Okay, so let's try some of these together using your sheet now. Here is your first your first problem. It says, Scott spent 3/4 of his money on comic books. He spent $9 on comic books. How much money did Scott have before he bought the comic books? Okay, so for this one, it's similar to my Julio and Esperanza problem. It says 3/4 of what, of some amount of money, equals 9. Because he spent 3/4 of his money. We don't know what his money was. And the 3/4 of that money equaled $9. So that would be really hard to figure out using the algorithm. But we could pretty easily do a tape diagram, because we can say we don't know what it is, but we know we need to cut it into 4 parts. And we know that 3 of the 4 parts has to equal 9. So 3 of the 4 parts has to equal 9. So what would these parts have to equal? That would be 3s. Which means our mystery number, or our unknown number, would have had to be 12. So 3/4 of 12 equals 9. And we could check that. We could say, what is 3/4 times 12? Well, 3 times 12 is 36, and 4 times 1 is 4. And if we did in and out, and we know our facts, 36 divided by 4 is 9. So we did get our answer. But again, the tape diagram is great for these unknowns that we don't really know. Okay, number 2 says, Tyler drew the angle shown. Okay, so this is Tyler's. I'm going to label it. Kayla draws an angle with a measure that is 8/5 the measure of Tyler's. Okay, so we don't know what Kayla's is. What is the measure of Kayla's? Okay, well, we know that Kayla's is going to be 8/5 of Tyler's. So 8/5 of 60. So that's 8/5 times 60. So for this problem, a number line wouldn't work because this is a greater than 1 fraction. We could do a tape diagram for this. I might just use the algorithm for this. So I might say 8/5 times, and remember it has to be fraction times over fraction. So we're going to multiply straight across. So 8 times 60. Well, 8 times 6 is 48. So 8 times 60 must be 480. And 5 times 1 is 5. So this would be a greater than 1 fraction because the numerator is larger. So let's find out what it is using our in and out strategy. So 4 cannot be divided by 5. That would be 0 times. 48 divided into groups of 5, we could make 9 groups. So 9 groups of 5 is 45. And 30, I can make 6 groups of 5. So 6 groups of 5 is 30. So Kayla's must be 96 degrees, and that's my degree symbol. Okay, ladies and gentlemen, in your packet, you also have some example pages you could use to help you. But on your homework tonight, you can solve however you would like on these 4 problems. Okay, you are welcome to solve them how you would like. I do suggest you try to fill these boxes in for number 2. You don't have to solve that part, but again, try to solve them in however works best for you. Have a great night.